Your task creation tool needs structured input, but you don't want to force users to fill out a form before they even know what's required. We'll see how to define a clean task details data class and use ctx. Elicit to interactively collect all the fields, title, description, priority, and due date, while handling user acceptance or cancellation gracefully.
From Dataclasses, import data class. From typing, import literal. At data class. Class task details. Title, str. Description, str. Priority, literal, low, medium, high. Due date, str. At MCP, tool. Async def create task, ctx, context, str. Create a new task with user-provided details. Result equals await ctx, elicit. Please provide task details. Response type equals task details. If result action equals accept. Task equals result data. Return F created task. Task titled priority, task priority. Return task creation canceled.
This demonstrates interactive user elicitation, a pattern for dynamically collecting structured input during tool execution. Unlike traditional APIs that require all parameters upfront, elicitation enables tools to pause mid-operation and request missing data, clarification, or confirmation from users. The distinctive feature is its bidirectional nature. Tools can adapt their workflow based on real-time user responses rather than following a rigid input-output contract. The pattern works by establishing a conversation flow where tools define what information they need when they need it. Using type hints and data classes, you declare the expected response structure, while the framework handles serialization, validation, and the pause resume cycle. This creates a clean separation between the tool's core logic and its interactive requirements, allowing complex workflows to emerge from simple, composable prompts. This approach solves the problem of incomplete or ambiguous inputs in automated systems. It's particularly valuable for AI integrations, administrative tools, or any scenario where requirements can't be fully specified in advance. The trade-off is added complexity in client implementations, which must handle these interactive prompts. But the result is far more flexible and user-friendly than traditional parameter-driven APIs. Let's break it down line by line.
From Dataclasses, import data class.
Imports Python's data class decorator to eliminate boilerplate in class definitions. It auto-generates init, repr, and other special methods, keeping the task details class concise while maintaining type safety and readability. This pattern is standard for clean data container classes.
From typing, import literal.
This imports literal from typing, enabling strict string value constraints. It restricts the priority field to only accept low, medium, or high, preventing invalid values at type check time.
At data class. Class task details.
This defines a data class for structured task information. The @data class decorator eliminates boilerplate code for init, repr, and other methods, while enforcing type safety through the annotated fields that follow. This pattern ensures clean data handling when FastMCP collects user input for task creation.
Title, str.
This defines a required string field for the task title. The data class enforces type safety, preventing invalid data types from being assigned to this property.
Description, str.
This defines a required string field for the task's detailed description. It enforces structured data collection, ensuring the AI-captured task details include meaningful context beyond just the title.
Priority, literal, low, medium, high.
This enforces type safety on the priority field, restricting it to exactly low, medium, or high. The literal type prevents invalid values at runtime, eliminating a whole class of validation errors before they occur.
Due date, SDR.
This defines a due date field as a string type in the task details data class. It captures the task deadline in a flexible format, allowing dates to be represented as ISO strings, natural language, or any other string-based format the system supports. The string type here prioritizes simplicity over strict validation, deferring format enforcement to the calling context.
At MCP, tool. Async def create task, ctx, context, SDR. Create a new task with user-provided details.
This defines an AI callable tool using the @MCP tool decorator. The function signature and docstring automatically generate the tool's schema, while the context parameter enables progress reporting and logging. All FastMCP tools follow this pattern for consistent AI integration.
Result equals await ctx, elicit.
This triggers FastMCP's interactive data collection. The elicit method pauses execution, prompts the user for structured input matching, task details, and returns either accepted data or a cancellation. This pattern handles dynamic user input while maintaining type safety through the response type parameter.
Please provide task details.
This is the user prompt for the ctx, elicit call. It defines what information the AI should request from the user, ensuring structured input collection before proceeding with task creation. The prompt's clarity directly impacts the quality of the collected task details data structure.
Response type equals task details.
This enforces structured input validation using the task details data class as a schema. The elicit call will only accept responses matching this type, preventing malformed task data while enabling IDE auto-completion for the expected fields. This closing parenthesis terminates the ctx, elicit call, finalizing the structured data request. It ensures the AI interaction waits for and validates the task details response before proceeding, maintaining the expected control flow.
If result action equals accept.
This checks the user's response action from the elicitation. It validates whether the user accepted the task details or canceled, determining if we proceed with task creation or abort. This is the standard pattern for handling user confirmation in FastMCP tool workflows.
Task equals result data.
This extracts the validated task data from the user's response. The result data contains the structured task details object after the user accepts the input, enabling direct access to the task properties like title and priority.
Return F created task. Task title priority. Task priority.
This constructs the success response using F-string formatting. It combines the task's title and priority into a user-friendly confirmation message, providing immediate feedback that the task was created with its key attributes. The pattern ensures consistent output formatting while keeping the response concise and actionable.
Return task creation canceled.
This handles the user cancellation case. When the user rejects the elicited task details, this return statement provides immediate feedback and terminates the tool execution cleanly. It's the explicit handling of the negative path in the elicit response workflow. Structured elicitation pattern. FastMCP's ctx, elicit, transforms Python type hints into interactive schemas, enabling AI models to collect structured data through natural language conversations. The response type parameter accepts data classes, enums, or literal types, but never nested objects, as the MCP spec enforces shallow validation only. This pattern bridges rigid code schemas with fluid human input, making AI interactions feel effortless yet precise.
The schema that disappears into conversation is the one most clearly understood.